So basically, OSHA limits for CO are set at 50 parts per million. Canadian CO limits are set at 25 parts per million. And the recirculation units, their certification limits are actually set at the Canadian's max limit for occupied space. So if you add anything to the space, like a forklift or other, they would pop above that at 25 parts per million. And, or if you degrade the burner in any way over time, like you rust out a cast iron pipe, you're still going to go above that limit. So Canadians don't allow 80/20 units in their space. The non-recirculating CO limits are down at 5 parts per million. And so there's a lot of room difference between 100% outside air and the recirculation technologies. The second indoor air quality impact is NO2. NO2 is it impacts sensitive adults. It's been linked to asthma, and any sensitive adult with at even as low as 1 part per million, they've got studies on sensitive adults actually being impacted. And so the green building guys are like, I don't want 3 parts per million of NO2 in my green building. I don't actually think that, what are you talking about? It's not even like in the right world. It is actually the OSHA limit, which is for industrial non-sensitive populations. It's the OSHA limit in Canada, and it's just below the OSHA limit here in the US. And so non-recirculating NO2 limits are at 0.5 parts per million. So these are just paper document differences, meaning without any other change to the system, no argument, this is what they say they do, this is what they say we do, and the difference is significant indoor air quality wise. And so they were floored by how recirculation units would think that they should be in green buildings. And they were like, I don't even understand. You guys, and so they were never presenting this data to the committee and saying you should be able to do 3 parts per million. They were simply saying it's safe. You guys don't know it's not safe, so we need to be in green buildings. And the green building folks said that doesn't cut it. In my opinion, if I see this as an engineer, I'm not putting in something that's got 5 times the limit or 6 times the limit on NO2 and 5 times the limit on CO, unless there's a viable reason, unless there's a compelling reason for me to do it as an engineer. And the reasons that could be there would be energy efficiency or cost. You know, I could make a compelling argument to negatively impact indoor air quality for that, but I would have to think hard about what my trade-offs are. And right now, I believe the engineering community does not even have this data. Yeah. And so, you know, the question that David asked, which is, are they going to start saying they do it downstream of the burner or upstream of the burner or downstream? That has nothing to do with this. This is certification requirements. Now, if you put the burn before the burner, you don't have any clue what you're burning, because if there's an indoor air pollutant, such as tire off gassing or any other thing, and it goes through the burner, then these numbers, these don't reflect those. So this is at certification limits, and that's new equipment.
Best case.
Best case. That's not. It's new equipment, and so they have to pass this level to get through certification. When we sit on the boards that set these limits, and when we have tried to get them to reduce those limits to 10 to 15 parts per million for CO, because we believe that Canada would accept a 10 to 15 part. They push back because their whole system is built around the ability to be able to combust uncleanly or cleanly enough to meet this limit. This limit's actually hard to meet in a recirculation limit. And so they have been hesitant as an industry to drive that down. They don't see any reason to do it. We see a reason to do it because we believe that indoor air quality should be better than that point.